Okay, here's the question then. Partial fractions question. So let's have a go at it. So here's the function. I've summarized the question. So here, what have we got then? We've got 6 plus x minus 9x squared over x squared x plus 2 is equal to, well, that's a linear factor, a over x plus 2. And this is a repeated factor, isn't it? So it's b over x plus c over x squared. Okay, multiplied by the denominator then. Gives, so we get this here then, don't we? 6 plus x minus 9x squared on the left. Multiplied by this here, and the x plus 2 cancels. We get ax squared. Multiply here, and one of the x's cancel. And then the c, when we multiply by this, the x squareds cancel to leave c times x plus 2. Okay, so that's what we've got then. So what should we compare? Well, we want values coming out easily, don't we? So if we compare constants, it's easy to spot that 6 and c must be 3, but we'll work it out then. So let's look at the constants. I'll put x equals 0, 6 on this side, and the constants on the other side will just come from this term here, 2c. So c is equal to 6 over 2, which is 3. Okay, so that's c. Now, if we compare x's then, we'll get b and c together, won't we, probably, looks like. So let's compare x's then. And then we'll get 1 on this side. And none there, bx squared, 2bx, so there's 2b. X is there, and there's a cx here. So that tells us then that 2b is equal to 1 minus c. C is 3, 1 minus 3 is minus 2. So that tells us what b is then, isn't it? B is equal to, move the 2 from times to divide. Minus 2 over 2 is minus 1. So there's b. Now we compare x squareds to get a, can't we? Minus 9 is equal to a here, lots of. And we've got a b lots of. So that tells us that a is equal to minus 9 minus the b, isn't it? We move it over. B is minus 1, so it's minus 9 plus 1. Minus 8. So that's a. So fx then is equal to a, which is minus 8 over x plus 2, plus b, which is minus 1 over the x, and then c is 3 over x squared, plus 3 over x squared. Okay, that's part A done then. Now part B, use A to find f dashed x and verify x. Fx has a stationary value at 2. So let's differentiate then. So here differentiating gives f dashed of x then. This is something to the minus 1, so the minus 1 comes to be with the minus 8. Multiplied by the something to the 1 less in power, so it's minus 2, isn't it? And we can write that like so. Multiplied by the something differentiated. So the minus 1 power comes here to make 8. This to the minus 2, which we write like this if we want. Here, the same happens again. Minus becomes a plus. 1 over 1 less, so it's x to the minus 2, isn't it? This is a minus 2, making minus 6 over x. 1 less would be cubed. Okay, so f of dashed x is equal to that. Right, so, and what does it say? Does it say simplify? I think I'm okay with that actually. So that's equal to 8 over x plus 2 squared plus 1 over x squared minus 6 over x cubed. Now part B, stationary point, isn't it? At x equals 2, verify. So let's have a look at that, part 2. At x equals 2 then, f dashed of 2 is equal to 8 over 2 plus 2 is 4, 4 squared is 16. 2 squared, 1 over 2 squared is 4. And minus 6 over 2 cubed, which is 8. So we get a half plus a quarter minus 3/4, which equals 0, doesn't it? So we verified that f part 2 has a stationary value at x equals 2. So f has point at the value x equals 2.